Welcome back to another tutorial video on Chapter 17 Chemistry for students. In this very short tutorial video we'll be looking at how to draw the electron configuration for some of the elements according to the Bohr model. You will remember from the history of the atom that Niels Bohr was one who discovered the orbitals of electrons moving around the nucleus of an atom after James Chadwick discovered electrons. Now we will only look at how to draw the electron configuration for the first perhaps 20 elements up to calcium using the Bohr model. Now these rules that you'll be looking at today are outdated in the sense that the idea of the atom has changed since the Bohr model into what we call the quantum model, which will be looked at later on. And the idea of orbitals and shells has changed drastically, but it's essential as a part of foundation chemistry you should be able to draw the locations of electrons around the nucleus of an atom for at least some of the elements according to Bohr's model. So let's have a look at how we do this. So first and foremost, there are some important rules that we need to remember when we draw electrons around an atom. And the first rule is, number one, the first shell of an atom can hold a maximum of 2. It can hold less than 2 but no more than 2. Once you have an atom that has more than 2 electrons, so for example after helium, which has 2, you will now have to have another shell. The second shell can hold a maximum of 8, again less than 8 but no more than 8, and then any more than 8 would mean you now have to create a third shell which can also hold a maximum of 8 electrons. Now this rule, as I reiterate, only is applicable to the first 20 elements. So let's look at how we draw the electron configuration here. So I have here an example of sodium. Now remember what I said in the last video here, do not learn these numbers as a top number or bottom number, because we can see clearly in this case here, sodium, they have put the mass number on the top and the atomic number on the bottom. The number I'm interested in with respect to knowing the number of electrons is this number here, because this is the proton number, and therefore we assume as atoms to be neutral they should have the same number of electrons as protons to cancel out. So let's have a look then. Start off with the middle, and I can write sometimes sodium there, Na, if there's any space. I've got 11 electrons I need to draw, and I need to fill up each shell at a time. So we start off with the center shell first, right at the start, and I've drawn my 2 electrons. Okay, so that shell is now complete. I now need to create or add the electrons in the next higher level energy level shell. So out of the 11 I've drawn 2, that means I have 9 more left to draw. So I'm going to draw them here. 1, 2, 3, 4, 5, 6, 7, 8. I have now completely filled up the second shell, and then that leaves me with 1 more left, because so far I've drawn 10 electrons and I had 11. I have 1 more left, and I will put that here for example. Okay, so the configuration for sodium according to this is 2 in the first shell, 8 in the second, and lastly 1 on the out shell. Let's have a look at another element here. This is chlorine. Again, chlorine has the atomic number of 17. So we need to now draw the electrons according to chlorine. So we'll start off again with the first shell. The first shell will be completely filled up because it can only allow to have 2, and they will easily be filled up. That leaves me with 15 left more to draw. So again, I know for certainty that this next shell will be completely full. Okay, so now I've filled it up. So that's 10 so far I've drawn, and I have now 7 left to draw to make up the total number of 17. That means I will have 7 electrons in the last shell there. So I'll put 1, 2, 3, 4, 5, 6, 7. And the configuration for chlorine will be 2 in the first shell, 8 in the second, and then 7 on its last shell. Let's have a look at magnesium, and you can have a go at these yourself if you're watching. So magnesium has the atomic number of 12. Okay, so let's have a look again. We will fill the magnesium up in the first shell. Those first shells are almost filled up in every single element there is, with the exception of hydrogen, which only has 1 electron. Okay, so we filled our first shell up. We know we've got 12, so we've drawn 2, so we've got 10 more to draw. That means the second shell will easily be filled. So that's going to be 8 in the second shell, and that leaves me 2 more left to draw, because look, 2, 8, which is 10, 2 more left. So I'll put them maybe there and there. So the configuration for this is going to be 2, 8, 2. And then we have oxygen, another final example here. Again, oxygen has an atomic number of 8, and therefore that means I will have my first shell filled up. So of the 8, 2 have gone into the first shell. That leaves me with 6 left on the second and final shell for oxygen. So I'll be 1, 2, 3, 4. Now I'm going to start to pair them up. 5, 6. Okay, so it'll be 2 and then 6. Alright, now let's talk about these last outer electrons. These last outer electrons are called the valent electrons. All this means is they are the last outer shell electrons. I want to show you another cool trick, so it saves you a lot of time on drawing them out often. You can use these numbers to predict what groups they're in by comparing them with what groups they're in. So for example, if we bring back my periodic table here, let's have a look. Sodium has 1 in its last of valent shell. There it is, 281. I will therefore look for sodium in group 1, which is there, and I can see here sodium is in group 1. Chlorine has 7 in its last shell, and I can use my periodic table to predict that chlorine actually is in group 7. It's going to be 7 there, and here it is. And I guess all of these elements in group 7 will have 7 in their last shell. And magnesium's in group 2, because the valent electrons in 2, and I can predict magnesium to be in group 2. And will all of these elements in group 2. They will all have 2 in the last shell. And you get the idea. Oxygen in group 6, it will have 6 in its last shell, and so will oxygen, sulfur, and the following. So that's it. As long as you are able to draw the electron configuration, this is the Bohr model for at least the first 20 elements. It's not more difficult than that. Just remember, when you draw them neatly, so it's easy to distinguish where they are. Now obviously we're aware in real life electrons are not placed like this. They are in groups or in shell orbitals around the atom. But for simplicity's sake on 2D, they often draw them as top, on the sides, and then at the bottom, on their own first, and then in pairs if they need to be paired up. Don't forget to write the configuration below each one as well, as 2, 8, 7, or whatever the number is. Alright, thanks very much for watching.